Alright, finally, we have, well, not finally, we have a couple more pieces after this, but we've got the general addition rule. General addition rule. This is the A or B part, okay, that we're talking about. The A or B part. And this is a rule that simply says, okay, well, that's where I actually get into the box again, because it seems to have not wanted to do that. There we go. Okay. Come on. There we go. Okay. If you want a probability of A or B, okay, you got two events, A and B, and you want to figure out the chance of both happening, okay, or the other happening, or, one or the other. It is probability of A plus the probability of B. Okay. But you need to subtract the intersection. Oops, A and B. Sorry. I'm using a little bit of a probability notation, which you'll see again if you take probability stats. Okay. All right. Let's break it down. Okay. Let's break it down. If you're talking about a Venn diagram, I'm going to draw those two circles again. Okay. This is a really quick example here. Okay. Okay, so here's my B. Here's my A. I'm going to use another color here to talk about this piece right here. This is actually right here. The P of A and B. Okay, P of A and B. Well, if you wanted P, A, or B, okay, you'd be adding the whole circles A, okay, and B together, like the whole space inside of it. But you need to take out this middle section. Why is that? Well, if you counted both of them without taking it out, you'd be double counting that middle section, because this is part of both events. But when we talk about A or B, remember, we talk about just shading the whole thing. Well, we only want one of the overlaps then. We don't want both. We don't want to double count it. That's why we subtract this part out here. If you need a little help on that, we can talk about it in class. So let's take a look at our examples here. At a high school, a student can take one foreign language each term. About 37% of the students take Spanish. About 15% of the students take French. Okay, so what is the probability that a student at random is taking Spanish or French? So, let's take a look-see here. %37 take Spanish, so Spanish, 37%. 15% French. Okay, out of the whole school. What is the chance that they take Spanish or French? Okay. Well, those two things are mutually exclusive. How do I know that? Well, typically, well, I guess the problem also says it, but typically you only take one foreign language every term. Because these two things are different languages, you can't have people in both Spanish and French. So if I were to draw the Venn diagram, for example, here's my Spanish group, and here's my French group. There's no overlap. So I simply add the two things together. 37% plus 15% is 52%. Okay, 52%. That's because there's no overlap. Okay, there was nothing to subtract because there's no overlap. But let's take a look at part B, example B. Suppose that in a certain part of the world, in a 50-year period, the probability of a major plague is 0.39, famine is 0.52, and plague and famine is 0.15. So what's the probability of a plague or a famine occurring? Well, let's break it down here. I've got major plague. That's 39%, 0.39. I've got famine, which is 0.52, and I've got plague and famine, which I'm going to represent with a plus, and that is 0.15. Okay. Well, once you've defined your events here, this is very simple. It's plus these two, that's event A and B, minus this piece, that's the middle part, the overlap. So 0.39 plus 0.52, that's 0.91, minus 0.15 should give you a grand total of 0.76. Okay, as my probability there. Okay, and so in the end, okay, you're basically looking at whether there is an overlap. And if there is an overlap, you just need to subtract it out from when you add the things together. This is still very basic, So hopefully you won't have to think too hard other than just labeling which piece responds to which event. All right. So very simple to do when you can just read the question and identify what's event A, what's event B, and so on. All right, last thing we're going to do today, I know, very long video, take a break if you need to, is modeling probability with Venn diagrams. So like I said at the beginning, these are very, very convenient to use. Okay, very, very convenient to use, but I'm going to actually do them with a little table. You'll know this as a two-way table in probability and statistics, which you'll know if you take that later, if you're not a senior already. Oops. There we go. So here are my events A and B. I'm just setting it up here so I can actually figure this out. Okay. So here are my events A and B. Okay. And we call this being male and having pierced ears. So here's my event A. Okay. I'm a male. Okay. And here's my event B. I have pierced ears. And finally, before I move on any further, I'm going to use this very nice pink color to tell you that the total number of people surveyed is 178. So this is your sample space, if you recall. Sample space total, let's call it. Okay, so pretty cool. I'm going to actually draw a pink box outside of this as well. Okay, so the pink box represents 178 people, but A and B represent what are my events. Okay, so let's take a look here and let's break it down. I have 90 people in the survey who are male. So I know there are 90 people in both here and the little overlap. Okay. In part B, okay, probability B, my total is 103. So I should write 103 in there. 103. Whoops. 103. Okay. And then there is an overlap. You see right here where there is both the black and the red circled part? Okay, I'm going to use the let's see, black and red combined make this kind of darker red color, so I'm going to use that brownish color. That's 19, so that's what goes in the middle. That's our overlap, 19. Okay. Now, knowing that, I have to just add 90 and 103, okay, 90 and 103 to get the OR part, and then subtract 19, which is going to be down here. Okay. For the purposes of this, you don't have to necessarily label the 178 part, but just so you know, this is all 178. All right. So that's an effective way of how to model your probability chart here, your two-way table. Okay. Figure out what your events are, figure out if there's any overlap, and then draw that situation. All right, let's take a look. I'm going to scroll down. Okay. After I do these ones, actually, let's go ahead and do these first. Okay. The probability of A. Okay. Well, should be using text rather. Probability of A. Probability of A is the probability of if it could actually work here. There we go. Probability of being a male, okay, in the study. Well, that is the total number of males, which is 90, divided by the total, 178. And that's simply it. If you wanted to simplify it using a calculator, you plug in 90 divided by 178, and you get 0.5056. Okay, so this is 0.506, let's say. That's about 50%, which, yeah, you would expect to be about right, I think. About 50% of people are males, right? And probability A and B. Well, that's what we set up here. It's that darker number. Okay. Probability of male and pierced ears. That is simply 19 divided by 178, right? And again, use your handy dandy calculator if you want the percent. Right? 19 divided by 178. That's about 10.7, okay, or 0.107. Okay, 0.107. All right, well, that was easy enough. I just took the number that I wanted and divided it out, right? That's pretty simple. Let's go ahead and move down to the last two here. Okay. and I am going to erase these two right here. P, or A, or B. So that is the probability. Yeah, it doesn't like doing this. Probability. There we go. Probability. Whoops. Of male or pierced ears. Okay. Well, again, that's, remember, our two numbers, our events, 90 for male plus 103 for pierced minus 19 for both, right? When we do that, though, we need to divide this whole thing, okay, by 178, which is our total sample space. You can feel free to do that at the end, but you should do all this addition stuff in the first place. Okay. So let's say you do that. I don't know why I moved it back up there. Okay. But 90 plus 103, let's go ahead and do that on the calculator. All right. Well, it's 193. That's more than the amount of people in the space, actually. So you should already know it's not 193 based on your knowledge of probability. So I do have to subtract that overlap. And when I do that, I'll have 174, okay, out of 178, which, if you use your calculator, is pretty high percentage. Something like 97.8%, 97.8, sorry. So you should automatically know, based on just the 90 and 103, that that number doesn't work in our definition of probability, so there's got to be a little more to it. We're using the right formula probably, but you need to subtract the overlap. Finally, we have probability of not pierced. Okay. This is actually pretty simple. I think we may have talked about it in the last episode, or the last video. But if you want to find out the probability of something not happening, you just take 1 minus the chance, okay, of it happening, which the chance of this happening is 103 out of 178. Okay, 1 minus 103 out of 178, which that number is about 57.9. Okay. So this number would be 1 minus 0.579, which is the same as 0.421. Okay, 0.421. Right. Now, I know this is a very dense episode, so make sure to take plenty of breaks. Make sure to review what you want to review. Okay. Most of this is only going to be tested on the final, and I feel like you just got to do more examples to really get it down. Okay. Use Venn diagrams whenever possible. They really help. Okay. If you figure out the definitions of A, B, A, and B, A, or B, the Venn diagram will 100% help you. Okay, so please use the Venn diagram to help you on your way with this lesson. All right. I'll catch you guys later. Hope you guys have a fantastic day. Peace.